What if everything you thought you knew about the universe was just the first page of a much larger, stranger book? For decades, we stared at a single photograph and called it the edge of everything. Now the James Webb Space Telescope has ripped that page out, revealing a cosmos built faster, bigger, and weirder than our theories could handle. It has fundamentally broken our models of cosmic evolution. What it found isn't just more stars, but a complete rewriting of the rules of existence. Let's delve into what Webb uncovered together. 10,000 galaxies. How do you map the universe? In 2004, you started by staring into absolute blackness. That's precisely what a team led by Stephen Beckwith of the Space Telescope Science Institute did. They aimed the Hubble Space Telescope at a patch of sky in the constellation Fornax, a region so empty it seemed pointless. For nearly 2 weeks, the telescope gathered ancient, faint smudges of light. When the images were combined, the result became legendary. The Hubble Ultra Deep Field. In an area less than 1/10 the size of the full moon, around 10,000 galaxies burst into view. Each one was a sprawling system of stars, gas, and dust, with some dating back more than 13 billion years. This wasn't just a picture, it was a time capsule. Hubble captured light in invisible and ultraviolet wavelengths, offering a window into the universe's chaotic adolescence. Spiral galaxies twisted like cosmic pinwheels, while distant blue clumps hinted at the earliest star-forming regions. For an entire generation, this single, breathtaking image defined the boundary of the observable universe. It became a cultural icon, demonstrating the sheer scale of reality and setting the benchmark for all astronomical surveys that followed. It was our best guess at the true scale of everything, but as we'd soon learn, it was a profoundly limited one. Hubble's limits. But here's the thing about a masterpiece. It can make you forget what's outside the frame. The Hubble Ultra Deep Field, for all its glory, had profound limitations. Think of it like this: the universe is expanding, and as it expands, light from the most ancient galaxies gets stretched. This process, called redshift, shifts light from the visible spectrum far into the infrared. Legendary infrared astronomer George Reek knew for decades that this meant a huge portion of cosmic history was simply invisible to telescopes like Hubble. Its vision, sharpest in visible and ultraviolet light, started to fade as it reached for the red end of the spectrum. It simply couldn't see the most red-shifted, ancient light from the era known as cosmic dawn. On top of that, thick clouds of cosmic dust acted like a celestial fog, blocking and scattering visible light. Entire populations of the oldest, dustiest galaxies were completely hidden from view. The field itself was also a constraint. Covering a tiny patch of the sky, it provided a deep but incredibly narrow slice of the cosmos, a view akin to looking at a forest through a straw. Astronomers had a keyhole view, but they lacked the broader context. Were these 10,000 galaxies cosmic rarities or just the tip of an unseen iceberg? The deepest secrets were waiting just beyond the edge of what Hubble could see. The Golden Mirror. To see beyond Hubble's limits, you don't just need a new telescope, you need a different kind of eye altogether. That's where the James Webb Space Telescope enters the story, and at its heart is an engineering marvel, a 6.5-meter gold-coated beryllium mirror. Led by senior project scientist and Nobel laureate John C. Mather, the team behind Webb knew that seeing the infrared universe required a radical new design. This mirror is nearly 3 times the width of Hubble's, and has more than 6 times the light-gathering power. It was built from 18 hexagonal segments of beryllium, a metal both incredibly strong and lightweight, which was essential for launch. Each segment is coated with a layer of gold, so thin you could stretch it around a football field, yet it's exceptionally reflective of infrared light, the exact part of the spectrum where the universe's oldest secrets are hiding. This mirror wasn't designed to replace Hubble, but to do what Hubble physically could not: peer deep into the infrared to see the first galaxies forming after the Big Bang. To achieve this, the entire observatory has to be kept incredibly cold, shielded by a 5-layer sun shield the size of a tennis court. It's an audacious piece of engineering, fine-tuned to capture the faintest, most ancient light in the cosmos. Seeing the invisible. So, how does a golden mirror translate into seeing back in time? Well, the magic is in the instruments that sit behind it. As the universe expands, ancient light gets stretched into the infrared. Webb was specifically built to follow these faint signals with its near-infrared camera, or NIR-CAM, and its mid-infrared instrument, or MIRI. These instruments can pierce through the cosmic dust clouds that blinded Hubble. The teams that developed them, led by principal investigators like Marcia Rikfernayar-Kam and Gillian Wright for MIRI, created the tools for a revolution. This technological leap paved the way for a new kind of survey, one that would capture both depth and breadth. Teams led by astronomers Caitlin Casey and John Kartal-Tepe pushed for an ambitious project called James Webb. Their vision was to use Webb's unparalleled infrared sensitivity not just to find a few more distant galaxies, but to map a huge swath of the early universe. This required incredible precision, using specific dithering patterns to move the telescope slightly between exposures to fill in the gaps on the detectors. They understood that seeing the big picture, the environment around the galaxies, was just as crucial as seeing the galaxies themselves. Webb's instruments make the invisible visible, transforming what was once missing data into a continuous record of cosmic history. 780,000 and counting. Prepare for a number that fundamentally changes the scale of our cosmic neighborhood. The James Webb survey set out to map the universe on a scale that makes the Hubble Ultra Deep Field look like, well, a family portrait. Over 250 hours, Webb swept its gaze across a region of the sky, roughly the area of 3 full moons. When the data came in, the team, co-led by John Kartal-Tepe and Caitlin Casey, cataloged nearly 780,000 galaxies. Let that sink in for a moment. That isn't a statistical estimate. Each one is a real confirmed system of stars and gas. For comparison, Hubble's iconic deep field found about 10,000 galaxies in a patch of sky 80 times smaller. Webb's survey is not only vastly larger, but also pushes nearly as deep, revealing galaxies stretching back over 13.5 billion years to within 300 million years of the Big Bang itself. The sheer volume of this data means astronomers are no longer just finding more galaxies. They are uncovering entire populations that were completely invisible before. Massive, red, dusty galaxies that Hubble missed are now filling the frame. This gives scientists the statistical power to understand cosmic evolution not as a series of curiosities, but as a predictable process. This isn't just a snapshot, it's a census. For the first time, we can move from studying rare, isolated finds to understanding the grand patterns and architecture of the cosmos itself. The cosmic web. What do you see when you can map nearly 1 million galaxies in one continuous sweep? You see the architecture of the universe itself. The James Webb mosaic reveals a breathtaking tapestry of filaments, clusters, and massive voids, collectively known as the cosmic web. This concept, first mapped in the 1980s by astronomers like Margaret Geller and John Hucra, is the universe's underlying structure, and Webb has rendered it in stunning detail. But the galaxies are only tracing what's really there: an invisible scaffolding of dark matter. As shown in simulations by cosmologists like Volker Springel, these sprawling dark matter structures stretch for millions of light years, dictating the fates of the galaxies within them. The filaments act as cosmic highways, channeling gas and galaxies into dense intersections where clusters form. Voids, on the other hand, are vast, empty regions where galaxies can drift for billions of years without encountering a neighbor. This new atlas allows astronomers to study how a galaxy's environment shapes its life. Graceful spiral galaxies tend to live in quieter areas, while distorted, irregular galaxies are often found along crowded filaments, their shapes warped by gravitational tides. For the first time, we're not just looking at a collection of island universes. We are seeing a connected, evolving landscape where every galaxy story is shaped by the cosmic geography around it. The infinity anomaly. Deep inside this new map, Webb found something that just shouldn't be there. Astronomers Peter van Dokkum of Yale University and Gabriel Brammer of the University of Copenhagen were sifting through James Webb data when they spotted a striking collision of 2 galaxies. The merger, seen nearly 8 billion years in the past, stretched the galaxies into a luminous figure 8, earning it the nickname Infinity Galaxy. But the real shock was at the heart of the merger. Theory predicts 2 supermassive black holes, one from each of the original galaxies, and they were there. But so was a third, off to the side, a rogue supermassive black hole with the mass of 1 million suns. It wasn't ejected from one of the galactic cores. Its velocity matched the surrounding gas almost perfectly, showing it was born right there in the chaotic swirl between the merging galaxies. This single discovery completely upends the standard script for how black holes are supposed to grow. It suggests that during violent galactic mergers, supermassive black holes can form directly from collapsing gas clouds, bypassing the slow, step-by-step assembly process once thought to be necessary. This has huge implications for gravitational wave observatories, as it predicts a whole new population of black hole mergers. The Infinity Galaxy is a cosmic anomaly that hints at a much faster, more chaotic path to building the universe's giants. Too fast, too early. The Infinity Galaxy isn't the only rule-breaker Webb has found. Across its field of view, the telescope is spotting galaxies that seem far too mature for their age. During a period known as cosmic noon, about 10 billion years ago, our models predicted a universe filled with young, blue, chaotic galaxies furiously forming stars. Instead, as pioneering galaxy researcher Sandra Faber and her modern counterparts have shown, Webb is finding giants that are already quenched. Their star formation has shut down, and their colors have faded to red. Some of these massive galaxies apparently lived fast and died young, gathering all their stars and snuffing out their own growth when the universe was less than a third of its current age. The processes that cause this, known as feedback, must be far more efficient than our models assumed. Even more confounding is the presence of orderly spiral galaxies with barred structures at redshifts where only turbulent, irregular shapes should exist. These galaxies rotate with a calm stability that should have taken billions more years to develop. The implication is unavoidable. Galaxies organize themselves and shut down their star formation far more quickly and efficiently than any of our models allow. The data from Cosmos Webb doesn't just fill in the map, it forces us to redraw it entirely. First light. Beyond mapping the cosmos, Webb was built for one ultimate purpose: to find the very first galaxies, and it delivered. In a survey called JWST, astronomers spotted a galaxy so distant its light began its journey just 290 million years after the Big Bang. Named JWST Z14-0, its distance was confirmed with an unmistakable spectroscopic signature. The team, including Stefano Carniani and Kevin Heinlein, used a technique that looks for the Lyman break, a sharp drop-off in a galaxy's light caused by neutral hydrogen absorbing all the shorter wavelength light. This cutoff left no doubt about its extreme distance. But the real surprise was what they found inside this fledgling galaxy: the chemical signature of oxygen. Oxygen isn't created in the Big Bang, it's forged in the hearts of massive stars and scattered across space only when those stars die in violent explosions. To see these heavy elements, which astronomers call metals, present in a galaxy this early means that at least one full generation of stars had already lived, died, and seeded the cosmos. This tiny, intensely bright galaxy proved that the early universe wasn't a place of slow, simple beginnings. Instead, it was a crucible where the cycles of cosmic birth, death, and recycling were happening at a breakneck pace. Rewriting the rules. The discoveries from the James Webb Space Telescope have thrown our timeline of cosmic evolution into disarray. What we're seeing is a universe that assembled itself with shocking speed. Galaxies were forming, growing massive, and shutting down far too quickly for our current models to explain. The evidence reviewed by senior JWST scientists like Dr. Jane Rigby points to a universe where the fundamental processes of galaxy formation, feedback from black holes, and the assembly of dark matter halos must be far more efficient than we ever thought. It suggests that the seeds of these massive structures were planted much earlier and grew much faster. The neat, orderly timeline is gone, replaced by a picture of a cosmos that was complex and structured almost from the very beginning. Yet, for all its power, Webb has surveyed only a tiny fraction of the sky. Every new image raises more questions. How did stable galactic disks form so quickly? What mechanisms quenched star formation so early? The scientific community is now in a race to find answers, planning wider surveys and using other telescopes to follow up on Webb's discoveries. The universe has shown its hand, and it's a far more interesting one than we expected. The bottom line is this: the universe isn't just bigger than we thought, it's fundamentally stranger and was built faster. The James Webb Space Telescope hasn't just given us a new window into the cosmos, it has shown us that our old map was incomplete, and perhaps completely wrong. Every square degree of the sky hides millions more of these rule-breaking galaxies, each with a story that challenges our understanding. The real frontier isn't just about distance anymore, it's about how quickly we can rethink everything we thought we knew about our own origins. Don't forget to like, subscribe, and hit the bell icon. Stay curious, and keep looking up. Thanks for watching Space Facts.